Hello, this is the second thin spherical lenses laboratory for Physics 430. In this one, what we're doing is we're verifying that you can indeed get an image of an object by using two regular lenses, non-concave. So two lenses with positive concavities, with two concave lenses rather than convex. So as you can see, we've built a little demonstration here of what is happening, where this image, or this lens, is focusing the image at about here, the midpoint between the two lenses. And what it's doing is it's creating a virtual object there. And as the light rays spread out from this point, the second lens then picks up on this virtual object as if the target here is sitting right here. That's what this lens sees. And it's spreading it out to become a new focus right here. And as you can see, we are getting the lens, or the image of the target on our plate here, and it is indeed being flipped vertically, because if you look at the actual object here, you can see the little arrow is on the bottom. It's kind of difficult to see if we zoom in a little bit. Yes, you can see the arrow is on the bottom here. However, on the projection of the image on the plate, the arrow is actually on the top. And that is indeed verifying that the setup with the distance between the two lenses being roughly double the focal length does produce an image of the same size as the object, but it is being flipped vertically.
All right. For this part of the lab, this is part 2, all that we needed to do was change the length for here it's from 0 to 100, and from here, which this part only changed because this part. The distance between lens 1 and lens 2 stayed the same. When we adjusted these lenses, we didn't move this or this. We only moved these two lenses, and it caused the image to stay in focus. This concept's still the same. The image does cross over, and we do notice that the image is still inverted. And all it does is it goes, crosses the vertical object, and then when it hits here, it refocuses on the other side. All right, in the third part of the lab, the final part, we are supposed to take this lens and have it 300 millimeters away from the image, which is more than 2f, or 2 times our focal length of the lens. Now what happens is, and now this is the 2f away as well, so from here to here is 256. Now no matter how far away we move this screen here, it will always be out of focus. So moving all the way out, always out of focus. Something that we notice while playing around with it is if we move this here, we'll find a place where it's focused, and that's as far as we can be to be able to focus an image.
All right, so now as Andrew was just saying, as you can see that the image here becomes out of focus no matter how far out you move it. But as you get closer and closer, you can see that it's getting more in focus, and that's because the maximum distance for the image is right here. And so the way, in order for the system to be able to focus an image, it has to be inside of that range. So you can see here, now it is focusing an image. And you can see the image is smaller, and it is indeed inverted, meaning that the magnification is roughly looking at it about -0.5. So again, this does verify the theory that in order for this system to focus a lens, to focus an image, the distance has to be less than 2f. Thank you.